Right, our last video for this chapter is on diverging lenses. Okay, a diverging lens, if you blow it up big enough to see how the curves on it looks like it's concave. But the point of a diverging lens is that when you send horizontal light beams into it, it actually makes those beams bend away from each other. Now, this is going to obey Snell's law, just like our converging lens did. The light rays are still bent twice as they go through, but when they come out on the other side, in place of coming together and meeting at the focal point, they're actually going to be diverging and coming apart. So, when we draw a ray diagram for a diverging lens, we actually have to think about where the rays are going quite differently than we did for a converging lens. So make sure that your thinking caps are tied on tight, because you have to really kind of, change your thinking as we're going through this. So we're going to work through example 12.6, and it says an object is 7 centimeters from a lens that has 5 centimeter focal points. And he didn't say it in the wording of the problem. He should have. He intended for this to be a diverging lens. And then he says, what's the appearance of the object if someone views it through this lens? Okay, so I have this drawn up here. Again, we're going to treat this lens just by looking at the center. If it's going through the center of the lens, that's how we're going to draw this ray diagram. So let's start off with a horizontal beam coming through. So if I have a horizontal beam coming in this direction, when it goes through this time, remember, these are not focused through the focal point. So in order to draw this beam as it comes through, it's going to appear that it is coming from the focal point on the other side. So it's going to come off this direction, okay? So I'm using the focal point on this side to get the beam that's coming off on this side, right? Now I'm going to use that same type of reasoning on the next one. I'm not actually going to send this light beam through this focal point. I'm going to say, let's pretend that this light beam is going to go through this focal point on the other side. So if I'm drawing the beam on this side, I have to look at the focal point on the other side. So when I do that, I'm going to take this and I'm going to draw this down this direction as if it's going to go through this focal point on the other side. And then when it actually goes through, it's going to come off horizontal. Like that. Whoop, that didn't show up, did it? I must have drawn it straight on the ruler. Let's try that one more time. That's better. Okay? And just like in our converging lens, let's see, I didn't use the red one yet. In our converging lens, the diverging lens is similar in that when it goes through the center of the lens, it's going to pass through undeflected. So I'm going to draw this one down like that. Now, again, you can see that these rays obviously are not going to cross, and so I'm going to have to extrapolate backwards to find out where my image is formed, okay? So I'm going to take this line and I'm going to extrapolate it backwards, so it's going to be right there. That one kind of disappeared, and then I'm going to take this marker and I'm going to extrapolate this one backwards, like this. And boy, that turned out almost perfect that time. Got really lucky, didn't I? So when I extrapolate those light rays backwards, I can see that my image is going to be formed right there, okay? So again, as you're drawing these light rays, what you have to think of with a diverging lens is I'm drawing it on this side, but I'm thinking of the focal point on the other side. So I draw this one horizontal. When I draw it out, it's coming from the focal point on the other side. When I draw this one on this side, as if it's going through the focal point, I'm focusing on the focal point on the other side and then drawing it horizontal. And then since they don't cross, I'm going to have to extrapolate backwards. So what kind of image is formed here? Because this has been formed by extrapolating the light rays, I have a virtual image. You can very easily see that this image is upright, and you can also see that this particular image is going to be smaller in size than the original, so it is reduced. So today you're going to get practice drawing ray diagrams for diverging lenses. Then you'll want to go in and you'll want to complete the chart that you started on lenses, just like the one you did on mirrors, and make sure you can see if you can pinpoint what those trends are as you move the object along a continuum based on where it is, based on where the focal point of the lens is.